Okay, in this video we're going to talk about gases. We'll define them and we'll roughly talk about when we encounter gases. So gases are simply molecules. They could also be atoms, but they are molecules that together they have no shape of their own. They actually take up the shape of the container they're in. They're not close to each other, so they actually try to expand as much as possible. And they do not have a definite volume whatsoever. They will take up the volume of the container they're in, and the container itself, if you can actually change it by expanding it or contracting, the gases will adapt to that change. And as far as measurements go, there's a number of them that you can carry out to characterize a gas. You can look at the pressure, which in SI units will be the atmospheric pressure. You could look at the volume of the gas, which, as I stated, can be changed at will. You could look at the temperature of the gas, usually in Kelvin, although as you'll find out, you could often refer to it in Celsius, but you'll have to remember to change it back to Kelvin. That's going to be a common trait for many of the things we'll do regarding temperature in this class. And the last one is the quantity of the gas. Now, the quantity could be either presented in terms of mass or it could be presented in terms of moles. But both of those quantities will actually be kind of equivalent to one another. And all four of these parameters, pressure, volume, temperature, and the quantity of the gas, give you the whole picture of what the state of the gas actually is. Now, one way to look at the state of the substance is via pressure temperature graph, in which you can actually define where the gases actually fall. And if you complete this phase transition diagram, what you'll find out is that gases appear on the lower portion of the graph, specifically in the territory where the pressure is low, but the temperature tends to be high. Although that may not necessarily have to be the case for temperature. Depending on the gas, you could go pretty low in temperature and still have a gas. But the general trait is that yes, the lower the pressure and the higher the temperature will ensure that you end up with a gas. On the upper portions is where you have the solids and the liquids, and transitions can actually happen between these particular states. So for instance, if you look at the liquid gas transition, what we're really looking at is the boiling point of the substance. And you can go from a liquid to a gas by undergoing one of two different transitions, or perhaps both. You could decrease the pressure, thus turning a liquid into gas, or you could increase the temperature, which will also give you the transition of going from liquid to gas. The same thing applies to the solid gas boundary, also known as the sublimation point of the substance. You could decrease the pressure, or you could increase the temperature to undergo a transition leading to a gas. And one last thing that I'll point out in regards to this diagram is that you have something known as the triple point. And so long as the atmospheric pressure is above the triple point, you will always undergo a solid to liquid transition before you can go to gas. However, if the triple point is above the atmospheric pressure, namely 1 atm, then that means that you will actually undergo a solid to gas transition directly. Now, to give you a frame of reference, here in this slide I'm showing the typical apparatuses that you do tend to use when dealing with gases. Here you have a fume hood filled up with a dual manifold, which allows you to pump in gas via this inlet. And at the same time, via this other inlet, you can hook it up to a vacuum pump that allows you to remove gases. So you, at will, can remove gases and introduce new gases into reaction vessel like the one you see right here. You could also trap gases using cryogenic liquids in Dewar tanks like the ones that you see right here. And speaking of Dewar tanks, these are the ones that contain a vast amount of gases. Some of them could be oxygen, some of them could be nitrogen, air, argon, but these contain a lot of gas under high pressures. And for reactions that do require high pressures, you could actually use stainless steel complexes, or not complexes, but stainless steel apparatuses like the one you see right here. For reactions that don't go past 2 atmospheres worth of pressure, you could actually use regular glassware, borosilicate glassware, like the one right here, and even Schlenker glassware, like the one that we see here on the right. But at all instances, you do need to use pressure gauges to find out how much pressure you actually have in your flask. Because if you accidentally overpressure something, you could end up with an unwanted explosion. All right, now another thing to mention in regards to gases is that when you look at the periodic table, the elements in particular, the ones that I'm highlighting here in yellow, probably by now you know that in their elemental form, they are gases. Some of them are diatomic, other ones are monatomic, like the noble gases. But these are gases, and what you'll notice is that the boiling point of these elements is very, very low. For hydrogen, we're talking about negative 252. For helium, we're talking about negative 268 degrees Celsius. This is some of the coldest temperatures that you can achieve. And generally speaking, liquid helium is what you use for cryogenic um, supercooling of magnets or electrodes, which are used for some instrumentation. But in general, the gaseous substances at room temperature have very low boiling points, very much in the negative Celsius region. And density, if you compare the elements altogether, look at the solid elements, they have regular densities ranging from like 2 to maybe 14, or in some cases even 25 grams per cubic centimeter. But when you look at the gases, the actual values are a lot less. We're talking about factors of 10 to the negative 3 for all of the gaseous substances, meaning that you actually occupy a lot more volume per mass of gas than you do occupy volume per mass of solid or mass of liquid. All right, now that basically concludes this particular video. In the next video, we're going to talk about pressure, and we're going to come up with all the different units involving pressure.